Hey guys, how's it going? Back again here with another example on introduction to limits. So let's just step right into it. We're going to look at example number 2. And I already have a problem laid up here. I'm going to step out of the screen. And there we go. All right, so remember that in the last video, I said that a limit is what the function value is approaching as we approach a particular value. So remember that key word of we are approaching. Again, we are approaching a particular value. So let's look at this one. So I have here set up is a piecewise function. So I see that when x is less than 5, we are on this function x plus 20. When x is greater than 5, we are on this function x squared. But when x is equal to 5, we are equal to 10. So now the question is, okay, as we approach 5, what value is this function approaching? So let's think about it. So we did last time was looking at it from a numerical perspective. So let's do that. I'm going to start by, remember that a limit will exist if we approach the same value from both ends. So I'm going to approach 5 starting first from the low end. So I'm going to approach 5. So we'll say like 4.8. And we're going to put it into the function that is appropriate. So according to our piecewise function, since we are plugging in a number less than 5, we're on this function right here. So plugging in a 4.8 would yield an answer of 24.8. Then if I get closer, 4.9 would yield an answer of 24.9. And as I keep getting infinitely closer, again, I never am going to plug in 5 itself. I'm going to keep getting closer and closer to 5. I see that my answers, my values, are approaching a particular number. So just to keep emphasizing here, so we could see that as we approach 5 from the left, so numbers less than 5, so as I approach 5 from one side, I am approaching the value of 25. Now in calculus, the way that we say that is we write it using this notation. So I say I'm approaching 5, and the little negative here in the exponent indicates that I'm approaching from that left side, numbers less than 5. So as I approach this, I would say my answer is 25. So that's what I am approaching. Okay. Now again, I'm not plugging in 5. Now what happens if we approach 5 from the other side? So if I did 5.1, now it's a number that's bigger than 5. So that means we're using this part of the piecewise function according to the conditions. I'm plugging in numbers bigger than 5, so we are on this part of the function. So 5.1 squared, and I'm going to go ahead and grab my calculator here because I can't do that in my head. If you can do it, I give you kudos, but I cannot. So I get 26.01. So there we go. So 26.01. And now we're going to keep getting infinitely closer, but from this side. So I'm going to say 5.01. And I'm squaring that, and I get 25.1001. Keep getting closer. Now I get 25.01. 0001. And again, just to really hammer the point home, I'm gonna plug it in even closer. And we get 25.001. 00001. So we get that. So we see that now when we come from the right side, so picturing again, here's 5 on a number line. So we came from the left, which would have been this, and now when I come from the right, so in limit notation, we would write it like so. I also am approaching 25. I'm going to call this here, I'm going to call this f of x, because we do want to, I don't want to write the whole piecewise function again, so I'm just going to shorthand it here. So when I come from either side, I see I am approaching is the value 25. So that means the limit exists, and I would then say that the limit as we approach 5 of this piecewise function is 25. Now, just to make a quick comparison, remember that in our first example, we had said, well, why couldn't we just plug in the number from the beginning? It was the same. Well, what would it have been here in this case? What is f of 5 according to this function? Well, if you plugged in 5, you would have said the answer was 10. So you see here that these two are not the same. So this is where, again, this is a perfect example of showing you that the limit is not necessarily going to be the same as the function value. We are looking at what the function is approaching. So again, keyword, key concept to keep in mind is the limit is what we are approaching, not what it is going to equal to. It is not the function value. It is what the function value is approaching. All right, so let's go ahead and we're done with this example, and I'm going to set up a new problem in the next video. So see you on the other side.